Welcome back to my YouTube channel. So today we are going to solve day 28 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 689. Maximum sum of 3 non-overlapping subarrays. Okay, so let's read the problem statement first. So we have given an integer array nums and an integer k. Okay, we have to find 3. Okay, so this is fixed, right? We have to find 3 non-overlapping subarrays of length k. Okay, k is given to us, right, with maximum sum, and then we have to return them. Okay, so here we have to return the result as a list of indices representing the starting position of each interval. Okay, if there are multiple answers, then we have to return the lexicographically smallest one. Okay, and these are the constant size given to us, right? So here in this is my nums array, right? So here let me just give the indexing here. So this is 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index, right, and 7 index. All right, k is equal to 2. Okay, so this is one subarray, okay, of length k, right? So at 0 index, this is one subarray, right, 1 and 2. So what is sum of this 1 and 2? Sum of this 1 and 2 is nothing but 3, right? So I can write 3 here. Okay, and if I take this subarray 2 and 1, then again sum is 3, right? Again sum is 3, and this is 3 is the sum of the subarray starting at index 1. Okay, and then this is one subarray, right, 1 and 2. Okay, and sum is going to be 3 here only, right? And this is subarray is this sum is the starting for this subarray, right, at this index 2. Okay, so here I can write 2. Okay, same way 2 6 8. Okay, 2 6 is 8. Okay, and 6 7 is 13. 7 5 is 12, right? And 5 1 is 6. Okay, so these are the different subarrays that I have. Okay, so 0 1 3. Okay, so from 3 index we are going to get this sum, right? 3 index this sum. From 4 index we are going to get this sum. Okay, subarray sum. From 5 index we are going to get this sum. Okay, from 6 index we are going to get this sum, right? So this is nothing but sum. Okay, so I'm just going to pre-calculate this stuff, right, initially, so that later on whenever I'm going to try to find out a sum starting from any particular index, so I have all these values available with me. Okay, okay, so that is why I have created this array. Okay, so here let's name this as my sums array. Okay, sums of array, sums array. Okay, and what is the length of this sums array? So length is 7, right? Length is 7, right, of this sums array. Or I can write it like this, length of this nums here 1 2 3 4 5 6 7 8. Okay, 8 is the length of this one. All right, so I can assign the length of my sums array as n minus k plus 1. Okay, so n is nothing but 8. Okay, 2 is nothing but a k value, and plus 1. Okay, so 8 minus 2 plus 1 is going to give me 7. Okay, so this is nothing but going to be the length of my sums array. Okay, so we have only these sub arrays. Okay, starting from 6. Okay, this is going to the max sub array, which is going to be have at 6 index. Okay, after 6 index I will not find any sub array of length k, right? So this is going to be the last index, okay, at which I am going to find a valid sub array, right? So that is why here I'm writing it right as n minus k plus 1. Okay, so this is one thing, right? So you can use sliding window approach, right? You know that window size is going to be 2 only, and then you can just pre-calculate all these sums. Okay, so this is one thing. Okay, initially this is just one basic thing. Okay, and one more basic thing that we know that we have to just find three non-overlapping subarrays. Okay, three, only three, right? That's what we need, right? So okay, so for that I'm just going to create one list. Okay, list of integers, and in this list of integers, okay, I'm just going to store the values. Okay, first value. Okay, if I have this value, then only two are remaining. So, okay, if I have this value, then only one is remaining. Okay, so in this list I'm going to store the indexes. Okay, all right, so these two are some basic things. Okay, now how we are going to solve this problem? Okay, so let's take this example. Okay, nums arrays 1 2 1 1 2 1 2 6, right? 7 5 1. Okay, 7 5 1. All right, so this is nothing but my nums array. Okay, here let me just give the index 0 1 2 3 4 5 6 and 7. All right, so now here what you are going to do? Okay, so here k is 2, right? K value is 2, which is given to us, right? And we have to find total 3 non-overlapping subarrays. Okay, so right now my remaining value, okay, my remaining value right now is 3, right? I haven't calculated anything here right now. Okay, all are question mark only. Okay, so remaining is 3. Okay, so now here what I need to do, so I have two options now every time, whether I want to consider this subarray or not. Okay, I have two options, right? Whether to take the subarray starting from 0 index or not. Okay, these are the two options that I have. Okay, so can I write it like this? Here, take, and here not take. Okay, I have two options now, whether I want to take the subarray which is starting from index 0 or not. Okay, these are the two options, right? All right, so here, okay, so here, yeah, one more thing. So here if you see this example number 1, so we are writing the output as 0 3 and 5. Okay, so see, at 0 index we have this subarray, right? 1 and 2. Okay, sum of this subarray is 3. Okay, and at 3 index we have this subarray 2 and 6. Okay, and the sum of this subarray is 2 plus 6 8. Okay, and at 7 at 5 index we have 7 and 5, and sum of this one is 12. Okay, so also we need to make sure that this sum is going to be max 3 plus 8 plus 12. Okay, this is also important. Okay, so I will show you how we are going to do that as well. Okay, so this sum should be maximum. Okay, because here we need with the maximum sum. Okay, with the maximum sum, so this sum should be possible, and we have to make sure that subarrays are non-overlapping. Okay, and then we have to give indexes. But here one more thing, if you take this pair, okay, 2 1 2 6 and 7 5, okay, then for this one also you are going to get the same answer, no? 3 plus 8 plus 12. Okay, same answer. Okay, so here instead of 1 2 I'm taking 2 1, so still we are getting the same answer, right? We are, but here in the output, then our output is going to be this 2 1 pair is going to start from 1, this 2 6 is pair starting from 3. Okay, and this 7 and 5 is going to start from index 5. Okay, so then we are going to get this output. Okay, if we select this 2 1 in the start. But here if there are multiple answers, then we have to done the lexicographically smallest one. So 135 and 035, so 0 is smaller than this one, right? Both are having same sum, right? But 0 is smaller than 1, so we are writing 035 as our output. Okay, so if there are multiple answers, then we return the lexicographically smallest one. Okay, so this is one important thing. Okay, now here let's move to this part. Okay, so we have two options now, whether to take the subarray sum starting from this or not. Okay, so right now my I is at this position, right? I is at this position. Okay, so now if I take this, okay, if I take this, then I have to solve like this. Okay, so then how I'm going to solve? If I take it, okay, then we know the sum of at this particular index, that is nothing but 3, right? sum at this index is 3. Okay, 3 plus I have to solve the remaining part. Okay, remaining part. So this is my remaining part. Okay, if I take this is going to be my remaining part then, right? 3 plus, and then after that I have to solve the remaining part. Okay, and my remaining part is going to start from this index, right? From this index my remaining part is going to start, right? So here can I write here as my index I? Okay, I can update it as 0 plus k. Okay, index. Okay, and all right, so here if I just write this complete array here, okay, for simplicity, 1 2 1 2 6 7 5 1. Okay, this is my array now, 1 2 1 2 6 7 5 1. Okay, so next time my I is going to be at this position. Okay, this is what I want to say here, 0 1 2 3 4 5 6 and 7. Okay, so this is what I want to solve, right? I is going to start from, but if I don't take it, if I don't take it, okay, then here let me just write the complete array, 1 2 1 2 6 7 5 1. Okay, so here then my I is going to be at this position. Okay, next time, right? I is just going to move one step forward. Okay, if I don't take this. Okay, but if I take it, then I have to make the jump now. Then I can't use an overlapping subarrays. Okay, my if I take this index, then I can't start from here now, then it will be overlapping, right? So that's the only reason. Okay, that's the only reason that I have to make a jump here, okay, to this position. Okay, and here my I is going to start from this position. Okay, all right. Okay, this is what I'm doing, but now how I am going to make sure that this is beneficial more for me, that if I take this index then I will get the better sum. Okay, here I'm saying that my remaining is 3, but if I take this then my remaining will be 2. Okay, if I take this, right? But here I want to make sure that, let's suppose this is going to contain my max sums. Okay, max sums that I have. How I'm going to make sure that if I pick this sub array which is starting at 0, then only I will get the best answer. How I can make sure, right? This is a question that we have in our mind. How we make sure, because I haven't visited anything yet. Okay, I just here take this. Okay, and then I have to make sure that using this only I will get the best answer. Okay, using this index only. Okay, how can I make a guess that this 0 should be there? Okay, and without the knowing about this 3 and 5. Okay, how can I make sure? So from here, from this part, I'm going to call one helper method. Okay, and this helper method is going to help me in calculating the sum. Okay, so here I'm going to call one helper method. Okay, and this helper method is going to find me the sum. Okay, in which I'm going to use this index as my starting point. Okay, and here also I'm going to call one helper method which is going to find me the sum, in which I'm not going to use this starting point as index. Okay, so two options now. Here in this part I'm using 3 plus the helper method. Okay, which is going to help me count the sum of remaining portion. Okay, using this. Okay, so what I'm saying, in this portion I'm using this 3. Okay, I'm using this 3, and plus I'm getting the sum. Okay, this is nothing but my take portion. Okay, and in this part I'm overall calculating the sum, but without using the index, without using 0 index. Okay, without using this one. Okay, without using I0. Okay, and here with using I0. Okay, with using I0. All right, so this helper method, okay, this is going to give me some sum. Okay, so let's say okay, let's say here I'm getting sum as 250. Okay, let's say here I'm getting sum as 250. Okay, not with this example, but let's say this part is giving me 250. Okay, and this 250 is sum I'm getting with using the I0 index. Okay, and here let's say I'm getting 220. Okay, let's say, and this is a sum I'm getting without using I0. Okay, so what does this mean? This means that it is beneficial for me to use this part, right? Because here I'm getting max sum. I'm using starting index, okay, for sure. And for the remaining portion, I calculated the sum, then I get the max 250 value. But here, without using that first position, 0 index, still I'm getting 220 only, okay, for I checked all the indexes, all the combinations. I have checked all the combinations except first one. I get 220. I have checked for the all the combinations plus the starting position. Okay, starting position plus this part 2 to 7. Okay, this part. So here I'm getting 250. This simply means that this value is greater, right? Take part is much greater, right? 250. So that simply means that in my list I have to add this 0 index. Okay, that's a simple part, that's a simple meaning of this one. Okay, because using this index I'm getting a much better sum. That simply means that we have to use this index. Okay, so I hope that you guys are clear how this is going to work. Okay, so yeah, this is one thing, right? And here, yeah, one more thing. Okay, so here I can write if my take is greater than equal to, okay, equal to y, this sum is greater than or equal to y, because of this thing now. Here 1 and 0. Okay, so if this is the case, then just pick the previous one only, right? This one only, right? With having the lower because of this lexicographical order, right? So that is the reason. Okay, so here this is what I'm going to write. So if my take is greater than or equal to not a take, okay, then just add the indices in the index. Okay, so now you clear now why I'm saying this. Okay, so let's suppose here I'm starting from 0. Okay, starting from index 0, right? And then starting from 2 index to n. Okay, all the values. Okay, 0 sub index, I know the sum is 3. Okay, and here for the remaining portion I'm calculating the sum, and here I'm not using the 0 index, but I'm starting from 1 to complete n. Okay, and here at the both positions I get the sum equal 20 and 20. Okay, let's say 20 and 20 I get. Then in that case, which index should I pick, this one or 0? So that is why I am preferring it. Okay, if it is greater than or equal to, then use this index only. Okay, so that is the reason, right? Clear? So if both are same, then just take one. Okay, this one, right? So this is what we need to do. Okay, so now let's write the code, and while writing the code I will also explain, okay, if any new thing comes, but this is what we need to take care, that's all. Okay, so now let's move to the coding part. All right, so here first of all, uh, inside this first, okay, so we can create one memoization array as well. Okay, memoization array as well. Okay, so we can store the value, right, at this particular index. If I know for this complete part what is the maximum I'm going to get, I'm going to store it. Okay, so later on if I again need it, I can use that. Okay, so from this part I'm going to store the remaining sum, from this part I'm going to store the remaining sum. Okay, right? Because here we are moving forward, right? Here take not take. Okay, so this is a simple recursion. If I take and not take, okay, so here also I will do this now, take this or not take. Okay, take this too or not take, and here also I will do this, take or not take. Okay, so definitely somewhere I have calculated, pre-calculated some values. Okay, so let's store them in db. Okay, so that we don't need to again and again do that again and again divide. Okay, so I have explained in one previous, there was one question related to recursion. Okay, I will add that link in the description of my this video. Okay, so in that video I have completely drawn the one recursion tree. Okay, full recursion tree. Okay, and in that case I have showed you how memoization works. Okay, how we are going to store memoization. Okay, so here this part is take and not take. Okay, so in this take part, okay, there may be some pre-calculated value here, okay, which I can use here. Okay, so instead of solving it further, okay, this part maybe I have stored this value somewhere here. Okay, so that will be helpful for TP. Okay, so here but what you can do here, just create one dp array. Okay, so private int dp. All right, and here inside this you can write first n value. Okay, n is nothing but nums dot length minus k plus 1. Okay, so this I have explained here. Okay, okay, so for this part I'm going to use that n minus k plus 1. Okay, n is equal to nums dot length minus k plus 1. Okay, this n I'm going to use, and my dp. Okay, so dp I'm going to store it new int, and here n. Okay, this n, because we are going to use these sums, right? So I will just store them. Okay, whatever index I'm going to use. Okay, at this 3 or 4. Okay, so at this dp I'm going to store the sums. Okay, pre-calculated sums that I have. All right, and here total how many columns, right? Or you can say number of arrays non-overlapping, so 3, right? So that's why I'm going to use 4 here, right? Okay, and now after that, here just completely do one thing here, for int row move our dp. Okay, let's fill all the values with -1. Okay, so arrays dot fill. Okay, all the rows with -1. All right, and then take sums array new int. All right, and now window sum. Okay, sliding window, let's use that. Okay, to calculate this pre-calculated sum values, right? Int I is equal to 0. Okay, take j as 0. Okay, now calculate the window sums. So while j is less than nums dot length. Okay, now here window sum. Okay, particular window sum is equal to window sum plus nums of j. Okay, and here I just calculate now if the window size, okay, j minus I plus 1. Okay, if it become equals to k. Okay, then in that case that we have got the value for a particular window. Okay, so in sum of I will just update the value, okay, of window sum. All right, and now window sum, okay, is equal to, I'm just going to update it with nums of I. Okay, so I will just subtract complete value. All right, nums of I, right? And then I'm just going to I plus plus. Okay, so that I move to the next index. All right, and always I'm incrementing the j, right? Simple. And here I have to give the result. Okay, so I'm just going to create the list of integer indices. Okay, array list, new array list. Okay, and here solve sums k 0 3 indices. Okay, so here in this solve, okay, I'm just going to pass the sums. Okay, the sums that I have calculated, sums array. I'm going to pass the k value. I'm going to pass index starting. Okay, so that is nothing but my 0, and 3 is nothing but the remaining. Okay, the remaining is 3 right now. Okay, so I have to find the remaining 3, right? All the 3's, and then I'm going to pass the indices. Okay, now I'm expecting this solve, okay, to give me the result. Okay, give me the list. Okay, so but the return here is array format. Okay, so let's just convert this array list, okay, this list of integers to arrays. Okay, so here but I'm going to write indices dot stream. Okay, or you can simply run one loop. Okay, for int I is equal to 0, I is less than this list size. Okay, I plus plus, and update all the values in one array. Okay, create one array of size 3 and just update the value. Okay, you can do that, or you can simply use this function. Okay, indices dot stream map to int. Okay, and here integer int value. All right, just convert it to array. Okay, that's it. Okay, this is done. So this is what we need to write here. Okay, now let's write this solve method. Okay, so here inside this solve method, okay, we have to write one solve method, right? So here you can write private void solve, and you know that in solve what we are passing now our sums array. Okay, sums array, and then we are passing k, then we are passing index, then we are passing remainder. Okay, not remainder, remaining portions. Okay, so here I am calling this solve method, right? So I am passing this and the indices list. Okay, so here list of integer. Okay, and here I'm going to write indices. All right, and now inside this, okay, so one few base condition, right? If remaining is equal to 0, all right, or if my index, okay, the index that I'm going to search for, if it is greater than equal to the sums dot length. Okay, so in that case simply return now. Okay, simply means that we are out of bound, and the remaining 0 then simply means we are out of bound. Okay, so simply here just going to return. All right, okay, now here inside this we have two options, whether to take it or not take it. Int take, int not take. Okay, so here if we are taking it, then just sums of index. Okay, that's why we have keep recalculated the values, right? So at particular index what is the sum and the remaining portion. Okay, in the remaining portion I'm going to call one helper method which is going to give me the sum. Okay, so in my helper method I'm just going to pass sums. Okay, k. Okay, and here my index, if I'm using it, so index plus k. Okay, so here index is equal to this position. Okay, plus k. All right, and here, okay, and here or and you can pass this remaining. Okay, so remaining we have to decrement. Okay, if we are using it. Okay, if we are using it, then we have to decrement the remaining part portion. Okay, if we are not using it, okay, if we are not using this index, then sums. Okay, and here index should be index plus 1. Okay, only one step forward. Okay, and the remaining it should be as it is. Okay, that's it. Okay, and here what we need to write, if take is greater than equal to not take. Okay, this I have already explained, right? Take is greater than not take, then in that case we are just adding the index. Okay, so I have explained it, right? This here take is greater than not take. Okay, if values are same and all that stuff. Okay, so if take is greater than this not take, okay, then in the indices I'm just going to add idx. Okay, and if I'm adding that index, then we have to solve the remaining portion. Okay, so here if I'm adding this index, then we have to solve the remaining portion. Okay, so in the remaining portion same thing I have to pass. Okay, so here sum k index plus k remaining minus 1 and indices. Okay, indices. Okay, so this solve method is going to help me adding the indexes. Okay, and this helper method is going to help me in calculating the sum. Okay, if I'm using that index or not. Okay, so yeah, solve is used to add the indexes, help is used to find the sum. Okay, and if I'm not using it, okay, else part, so again call this solve. Okay, now here index plus 1. Okay, and the remaining, okay, it should be like this only, right? And indices, right? So that's it. Okay, so this is done. All right, so this is where it ends. All right, so yeah, now we are done with solve. Okay, now we are just finding with this helper. Okay, and this is very easy. very easy. All right, to calculate the sum. So how we are going to calculate sum? Okay, so let's write that piece of code. So here, can I copy this completely? Let me just copy it. Okay, so here it is used to find sum now. So here write int, and instead of solve we have to write helper. Okay, and here int sums, int k, int index, int rim, and this is not required. Okay, the remaining and this is not required. All right, so now here if remaining becomes 0, okay, if my this remaining becomes 0, then in that case simply return 0. Okay, few base conditions, right? And here if the index becomes greater than equal to sums dot length, that simply means that we are out of bound. Then in that case simply return, okay, we have to return something because int is a type now. So here I'm writing integer dot main underscore value. Okay, now, okay, all right, so this is done. And now once this is done, then after that we have two options now, int take and not take. Okay, int take and int not take here also, okay, in calculating the sum as well. But here, so here you can just copy this, okay, sums of index if we are taking it. Okay, so we have to proceed further, and if we are not taking it we have to use this. Okay, so sums of index plus helper sum k index plus k remaining minus 1. Okay, if we are not taking it, then helper sum k index plus 1. Okay, inside this I'm calling this itself. Okay, for the remaining portion I have to calculate the complete sum. Okay, so now instead of doing it for all these solves again and again, okay, this here I'm calling this solves, and here I'm calling this solve. For this solve I'm again going to solve this complete part, and then take and not take. For this solve also I'm going to solve all this complete take and not take, then again and calling. Okay, so let's store the value now. So let's store the value. Okay, at this index, okay, and at the remaining, okay, at this value. So we are just going to store it. Okay, so that again and again we don't have to recalculate. Okay, so here that is why I'm going to use this memoization. Okay, dp of idx rim. Okay, here it is equal to math dot max of take and no take. I'm just saving it value, saving this value. Okay, and here I'm just going to return dp of index and remainder. Okay, so whatever the value we have. Okay, so here in dp index and remainder we are just storing the max value from take and not take. Okay, and here I'm just going to return that. Okay, and here one base condition will check if, okay, initially in the dp all the values we have filled as -1, right? So here just one base condition. Okay, if dp of index remaining, if it is not equal to -1, that simply means that we have pre-calculated this value somewhere. Okay, then in that case we have to just simply return from here itself, okay, the value that we have stored. That's it. Now let's run the code and see if there are code issues. Okay, so here I think we need to write sums now. Where is that? Where is the error? 1 second, let me zoom it. Here it should be sums now. Okay, let's run it again. Okay, all the test cases has been accepted. Now let's submit it. Okay, so see, our solution is accepted, right? And the time complexity for this problem, it is going to be of n. Okay, the reason is that we are simply storing all the stuff in a dp array, right? So here this portion is going to take just of n. Okay, of n into 4, so n only. Okay, and we are just iterating over all the values, right? And we are just pre-calculating the sums here, and then we are calling this solve. Okay, and now in the solve, if you see, we are calculating this take and not take. Okay, okay, and for take and not take we are calling these helper methods. Okay, and inside this we are calculating this take and not take. Okay, so instead of solving it again and again, we are just storing the max value in this dp of idx and remainder. Okay, So here we are just storing the value so that next time we don't need to recalculate everything. Okay, whenever we are going to call these indices with the same remaining portion. Okay, so we are just storing everything, so that's what it makes it as a time warp stage of n. Okay, so I hope that you guys are able to understand today's problem, and if you guys still having doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.